You ever heard this word binomial? That's monomial, binomial, trinomial. In polynomials we have seen. Okay. So binomial means what in that? It has two terms. Okay. So we have two terms. Let us say x plus y. This is a binomial, right? This binomial, yes man, raised to the power 1, and just note down their coefficients. Oh, power 0 will start. This binomial power 0. What is the value, you know? 1. Anything power 0, 1. Suppose the power is 1. It is x plus y. So x plus y, just list out the coefficients. So that is 1, 1. Okay. And x plus y whole square. We got x square 2xy plus y square. Now you just write the coefficients. That is 1, 2, 1. Okay. One shape is forming, right? X plus y whole cube. That is x cube. Come on. So okay, x cube plus 3x square y plus 3xy square y cube. Now write out the coefficients. That is 1, 3, 3, 1. Okay. And x plus 1. Okay. See, power 4, man. Is it possible to say? Power 3 itself we don't know. Power 4. What if I told you this 1, 4, 4, sorry, 1, 4, 4, 6. See, as you observe the pattern, if the power is 0, we get 1. Okay. If the power is 1, that is x to y. Alright. The power is 2, x square, and then 2xy plus y square. That means here also y is there, man. With y power 0. Okay. And here x power 1, y power n. Here as x power is decreasing, y power is increasing. Okay. X power is decreasing, x square to x it goes. Y power 0 to y power 1. Then from 1 to x power 0 it will go. And then y will be raised. Where x is decreasing, y power will be increasing. The same way look at here, the pattern you observe. Now it is easy. It is x power 4, y power 0. And then next what should come? X power should decrease, y power should increase. And x power decrease, y power increase. X power decrease, y power increase. X power decrease, y power increase. The coefficients. The coefficients are this one 1, 4, 1, 4, 6, 4, 1. All the things are plus. Okay. We got x plus y whole power 4 formula. What do you think? X plus y whole power 5. Good man. X power 5, y power 0. Y power 1. Perfect. Okay. Okay. Super. X power 0. Now the coefficients. See, just observe the triangle, man. Here and all, no problem. Here, when you say, see, man, these two numbers should be added. 1 plus 1, 2. This 1 plus 2, 3. 2 plus 1, 3. Next, 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. Then next 2. or it must be 1 plus 1. We should first one is 1, next 5, 10, and then 10, 5, 1. Now the coefficients are 1, 5, 10, 10, 5, 1. Everything plus positive. What do you guess x plus y whole power 6? Same like the triangle goes on. Okay. So the idea is, x plus y whole square, but the increased power we don't know. It is helping us to find what is the increased power. So for that we should observe the pattern. So far this variable powers we observed, man. The problem is with the numbers. We can't draw up to that last. Suppose x plus y whole power 25 is there, means is it possible to go up to 25? No, it is not possible. So we should observe the number. So for that we have a notation called combination notation. Heard of this permutation and combination? Permutation means we see NPR. That means n factorial by n minus r factorial. And the combination. Good question. Combination means it is NCR like we'll write. So that is n factorial by r factorial into n minus r factorial. See, that factorial is nothing but it's a product of numbers. Okay. Let me write here factorial notation. Suppose they say 5 factorial means it is 5 into 4 into 3 into 2 into 1. Okay. 3 factorial means 3 into 2 into 1. Okay. And like that 0 factorial value is 1, man. This is very important. 0 factorial value is 1. And this in general n factorial means from n everything should be multiplied. N into n minus 1 into n minus 2 up to 1. Usually we will write this n factorial is equal to n into n minus 1 factorial. That means here 5 factorial is there, right? That can be written like this 4 into 3 into 2 into 1 is what? 4 factorial. Okay. So that 5 into 4 factorial will write. That is what n into n minus 1. Okay. I think you have seen that what permutation combination you don't know, right? I'll simply say what is permutation, what is combination. Yes, that is what. See, this one is nothing but a number of arrangements. Like you have that 3 persons in your class. I am calling 3 persons to the stage. Okay, how many ways they can be arranged? Like they can be standing. Like that person 1, person 2, person 3 will be there, right? So it is either 1, 2, 3 like we can arrange, or 3, 2, 1 like you can arrange, or 2, 1, 3. Like that, how many possibilities are there? How many possible arrangements are there? 6. So instead of calculating like this, so we have 3 places. The first place will have how many persons? 3 persons. 3 choices will have. Second place, 1 person already standing here. Then here we have 2 options. Here we have 1. So totally 6 ways we can arrange them. That is what we call it as a permutation. Okay. How many ways we can permutate? Like simply you saw that Onion movie. You saw that Onion movie, right? In that Onion movie, there will be one comedy scene. Whereas that Vivek will be saying that 5 into 4 into 3 into 2 into 1 permutation badi kalakna, like that one dialogue will come, right? It's a very old movie, but they will be discussing like this. There will be jumbled words. Those jumbled words they will be rearranging like that. So here I arrange that persons, right? 3 persons. How? So that way they are about to arrange those things, write all the possibilities, they are going to cross out one. Like that. Number of arrangements is permutation. That is the thing. And then combination. Combination means I called 3 persons, right? But in the classroom, totally how many persons are there? Many. 40 students are there. But I called only 3. How many ways we can choose those 3 persons? The number of ways of choosing is given by this combination. Whereas n alternatives are available. You have 40 students in your class. I am calling 3 students. How many possibilities will come? That is what this 40C3. So we will be having 40 factorial by 3 factorial into 40 minus 3, 37 factorial. Okay. Now we can expand this like 40 into 39 into 38 into 37 like that. So we'll be having 40, 39 into, yes, the same thing. Here we have 3 factorial. 3 factorial means 3 into 2 into 1. And then 37 factorial will be cancelled. Now this can be simplified. 2 means here 20, 3 means 38 will get cancelled. No, 39 will get cancelled. So we'll get 20 into 13 into 38 number of possibilities of choosing 3 persons from your class. Okay. But we are not going to see those things and all. Permutation, it is number of arrangements. Combination is number of selections. Permutation also same, man. I called 3 students, right? We are talking about same example only. The 3 students, I am going to make them stand in the assembly. Working out now, like this one, 3 into 2 into 1. See, man, the point is not about permutation and combination. Just to introduce you what is combination, I told all these things. Shall I erase this? Okay, this formula workout you want, right? Except factorial. Okay. See, it is not about this permutation and combination. Simply introducing new things. That's why I am saying all these unnecessary things. See, we have okay. See, man, 40 students are in your class. Given n dissimilar things, there are few types also there. So in that we are choosing 3. It is 40C3. Choosing. After choosing, the arrangement is 40P3. Sorry, 3P. Sorry, I mean 3 factorial. Okay. Alright. So that is what. So here 40 persons available. I am taking 3. So 40C3. After taking these 3 persons are standing. I am going to arrange them. This is person 1, person 2, person 3. So 3 persons are available. I am permutating, I mean rearranging them. How many persons I am taking at a time? 3 persons. Okay. Okay. Then we will be having this 3 factorial by 3 minus 3 factorial. 3 minus 3 factorial is 0 factorial. So we will be having 6 kind of arrangements. But choosing that, we have this one. You want me to work this out again? Like the formula is n factorial by r factorial into n minus r factorial. So this one has a relation with this triangle then. See here, in general, we will start writing the formula. Shall I erase everything, the remaining things? They are all the useless things, shall I erase? This combination formula alone you just get to know. That is NCR is equal to, here let me write. NCR is equal to n factorial by r factorial into n minus r factorial. Now x plus y whole power n. I am going to generalize this one. Okay, that generalization, you know the power, how it works. It starts with the highest power for n, I mean x. Okay, then with y power 0, we don't mention that here, or if possible we will mention also, not a problem. Then x power reduced by 1, y power increased by 1. Then x power reduced by 2, y power increased by 2. Okay, you know this format, right? And so on. Here y power n, no problem. But the coefficient should follow this kind of same kind of generalization, right? For that only we are using that NCR combination. So here the n value is 0. Is it? And R value, that is n value 0, right? Then we'll be having here NCN. Sorry, NC0. Okay, R power 0. Okay, first term NC0, and then NC1. Why I am saying NC1? So this one will take and compare. This value is 3C0. This value is 3C1. This is 3C2. This is 3C3. Now you got confused, I think. Calculate 3C0. How much it is coming? The same formula, NCR. That is R means that is number of terms. Like this is the first term, second term, like we'll do, right? That kind of one notation. But the R don't have any kind of this particular term and all will not mention. I'll tell you while doing telling about the general term. General term now we have write like T R plus 1, like we'll write. Like it is always one ahead, one more than that what we are substituting. Okay. First we just observe. This is 3C0, like NCR. Then 3 factorial by this R factorial means that 0 factorial into n minus R factorial, that means 3 minus 0 factorial. Then how much it is? 3 factorial by 1, 0 factorial 1 I said, right? And then 3 factorial. So 3 factorial cancel, the answer 1. Okay. So we are trying to relate this number 1 with the power. This what comes for x plus y whole power 3, right? So with the power we are trying to relate this number 1. Like 3C1 we will calculate. What will come? Same thing. 3 factorial by, instead of 0 factorial we will be having 1 factorial into 3 minus 1 factorial. So we have 3 factorial by 1 factorial means 1 only. 3 minus 1 factorial, that is 2 factorial. Okay. So this 2 factorial and 3 will get cancelled. We will get 3 as the answer. Or we can expand 3 into 2 into 1. Here 2 into 1, 2 into 1, 2 into 1 cancel 3. This number. Can you guess what this 3C2? In place of R we are substituting 2. Okay. This few minutes of silence. Yes, ask me. Okay. You got 3 as the answer? Okay, now guess what this will be? This is x plus y whole power 4. This will be what? 4C0. Okay. And this is 4C1, this is 4C2, 4C3, 4C4. Okay. and this is x plus y whole power 5. This one is what? X plus y whole power 0 we got. 0 C 0. No. 0 C 0. We'll take. And this is 1 C 0, 1 C 1. This is 2 C 0, 2 C 1, 2 C 2. Okay. You observe the pattern. Okay. Now, this is in the shape of triangle. You noticed? Okay. See, this is in the shape of triangle, man. That triangle, we are calling it as Pascal's triangle. Why we are calling it as a Pascal's triangle? Someone named Pascal, that rascal, did all this in his free time. That is why we have to study all this. That is why he named after his name, Pascal's triangle. Okay. Now guess what? 3 means starts with the 3C0, 3C1, 3C2 and all. Now I am starting with the n. So this is NC0, NC1, this is NC2, at last NCN. Okay. This expansion is called binomial expansion. We have expanded the binomials to n terms. Okay. And these coefficients, we can make some observations on this, man. That observation is, if the power is n, it will be having n plus 1 terms, because I told you know that r, 0, r not you asked, right? What is r? That r is the number of terms in the expansion. See here 0, power 0 means we will be having 1 term. Power 1 means we will be having 2 terms. Power 3 means, power 1 means what, man? This is x plus y whole power 1. We have 2 terms. Then here power n means totally how many terms will be there? N terms. So this expansion is having not n terms, n plus 1 terms. 1 more than that power always. Power 0 means 1, man, 0 plus 1. Power 1 means 2 terms, 1 plus 1. Power 2 means 3 terms. Okay. Now it is having n plus 1 terms. And we have this first number and last number equal always. First term and the last term are equal. Not only first and last, second and second last term will be equal. Third and third last term will be equal. Why? Because we have the formula NCR is equal to NC n minus R. Sounds quite confusing. See, this 4C3 will be equal to 4C4 minus 3. You calculate 4C3 will be what? 4 factorial by, yes sir, by observation. See, 3C0 is equal to 3C3. 3C1 is equal to 3C2. Are they equal or not? So 3C1 is equal to 3C2 if you are getting means, this can be written like 3C3 minus 1, shall we write? That is what this NCR is equal to NCN minus R. Okay. And this R value is always less than or equal to N1. It will not exceed N. Okay, that's all. And some more observations. Like first and last is equal, first and is having n minus 1 terms, sorry, n plus 1 terms. And some other observations could be done. That is the binomial coefficients. This NC0, NC1, NC2 and all is there, right? They are called as binomial coefficients. NC3 up to NCn. Simply the coefficient, the numerical coefficients of the term. Okay. That is called binomial coefficients. And sometimes it is referred as, instead of NC0, they simply put C0, C1, C2, C3 and Cn. Okay. C1, C2 like our classroom names. And binomial coefficients. And rth term from the end. Rth term from the end is n minus r plus 2th term from the beginning. Initially we are not using these formulas. Like in the next aim maybe it is very useful. Okay, it is given means we may be useful, but after knowing that general term like we'll just summarize all these things. By the time this formula is useful. Okay, rth term from the end in the sense, suppose we have 5 numbers like 1, 2, 3, 4, 5. I want rth term from the end. That's what I am explaining. See, we have 5 numbers, or let it be 6 numbers. The third term from the end is what? 4. Okay, I mean the 4th number, not 4. From the beginning it is 4th number, right? So I asked the third term from the end. So this is what? R value. Okay, totally how many terms are there? 6. Okay, so 6 minus 3 see man, from the end I am saying. From the end third term is from the beginning 4th term. Yes man, third term from the end man. Oh, the arrow mark you confused. Okay, third term from here, then this is what R value will take. Totally 6 terms are there. We are looking for third term plus 2. N minus R plus 2. Yes man, 5 is coming. Third term from the end is 4 only we have. Totally 6 terms. Did I miss anywhere? No. The 3 is the R value. Okay man, but I am asking third term from the end, right? Totally we have 1, 2, 3, 4, 5, 6 numbers. Okay. Then 6 minus 3, we'll investigate, plus 2. Okay. Third term from the end is what? 4. This is the answer. No man. Third term from the end I asked, it was clear. And totally we got 6 terms. Then we got 5. It must be the 5th term. But 5th term is not the third term from the end. Somewhere it is missing. I may have given a wrong example. I'll come up with a good one. Then we'll discuss about this while seeing the general term. Alright. Then some more deductions of this formula, man. Shall I erase everything?